After you've defined a pod security policy, you need to authorize it. Otherwise, it'll prevent any pods from being created. You can authorize a policy by using Kubernetes role-based access control. Here, a cluster role allows the pod security policy called demo-PSP to be used. Next, define a role binding to bind the previous cluster role to users or groups. In this example, two subjects for the role binding are specified. The first is a group containing all service accounts within the demo namespace. The other is a specific service account in the demo namespace. The role binding can grant permission to the creator of the pod, which might be a deployment, replica set, or any other templated controller. Or it can grant permission to the created pod service account. Granting the controller access to the policy would grant access for all pods created by that controller. So the preferred method for authorizing policies is to grant access to the pod's service account. Without a pod security policy controller, pod security policies mean nothing. You need to both define the policies and to enable the pod security policy controller. Be careful here, the order matters. If you enable pod security policy controller before defining any policies, you've just commanded that nothing is allowed to be deployed. In GKE, the pod security policy controller is disabled by default. If you choose to use pod security policies, first define them, and then enable the controller with the gcloud command shown here. Name represents the name of your cluster. You can take additional security measures in Kubernetes, and many of these are enabled by default in GKE, especially if you choose to run recent versions of Kubernetes in your GKE cluster. For example, GKE's default policy of using Google's container-optimized OS for nodes improves node security. Unlike a general-purpose Linux distribution, the container-optimized OS implements a minimal read-only file system, performs system integrity checks, and implements firewalls, audit logging, and automatic updates. You can enable automatic node upgrades to keep all of your nodes updated to the latest version of Kubernetes. You can choose to run private clusters, which contain nodes without external IP addresses. You can also choose to run a cluster control plane for a private cluster without publicly reachable endpoints. By default, private clusters do not allow Google Cloud IP addresses to access the cluster control plane endpoint. Using private clusters with authorized networks makes your cluster control plane reachable only by specific IP address ranges that you choose. Nodes within your cluster's VPC network can still access the control plane, and so can Google's internal production jobs that manage it for you. Don't forget to take advantage of encrypted secrets to store sensitive configuration information rather than storing them in config maps. Whenever possible, grant privilege to groups rather than to individuals. This applies to both Cloud IAM, which lets you grant roles to Google groups, as well as to Kubernetes ORBAC, which lets you bind roles to Kubernetes groups. Suppose you grant privileges to an administrator named Pat in many places, and then Pat leaves your company. Now, you need to track down all of the places where Pat has privileges and remove them. That's tedious and error-prone. If you'd followed the best practice of always granting privileges to groups rather than to users, you can remove Pat's access simply by taking Pat out of the administrator group. The Kubernetes dashboard is a traditional add-on to Kubernetes. It was originally intended to provide a convenient web-based way for administrators to manage a cluster. In the past, the Kubernetes dashboard was backed by a highly privileged Kubernetes service account by default. Kubernetes dashboards were also often left accessible from the internet, and this was a serious problem. The default configuration exposed an interface that might be vulnerable to remote attacks. GKE takes steps to reduce this risk. GKE clusters running Kubernetes version 1.7 or higher do not give the Kubernetes dashboard admin access. GKE clusters running with Kubernetes version 1.10 or higher completely disable Kubernetes dashboard by default. Instead of using the Kubernetes dashboard, use the Cloud Console's built-in GKE dashboard or the kubectl commands instead, just as you've been doing throughout the specialization. These interfaces provide all the old dashboard's functionality and more without exposing an additional attack surface. If you must run an earlier version of Kubernetes, Google recommends that you disable the Kubernetes dashboard or at least restrict its permissions.